Hello everyone, this is Mr. Mola for the 9.1 video, Properties of Radicals. So first let's talk about what a radical is. So radical, you probably might know the definition for. So a radical is just really a square root that we don't know. So like we know the square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. But then like what about like the square root of 20? Like do we just leave it a square root of 20? So there's a way that we can simplify square roots that we don't know, even if they don't have a nice perfect answer. So there's some rules we need to be aware of. So what happens if we add square roots? So are they the same? If we just add square root of 36 plus the square root of 64, is that the same thing as saying the square root of 36 plus 64? So square root of 36 is 6. Square root of 64 is 8. 6 plus 8 is 14. Okay, makes sense. 36 plus 64 is 100. Square root of 100 is 10. So I get 10 and 14. Those are not the same. So addition doesn't really work for adding square roots. Okay, what about multiplying? Square root of 4 is 2. Square root of 9 is 3. And so we have 2 times 3, which gives us 6. Or 4 times 9 is 36. And the square root of 36 is 6. So multiplying does work. 6 does equal 6. Subtracting. So square root of 64 again is 8. Square root of 36 again is 6. So 8 minus 6 is 2. If I subtract them, square root of 64 minus 36 is really the square root of 28. And the square root of 28 is about 5.29. So it doesn't work for subtracting either. So adding and subtracting don't work. Multiplying does work. Let's see if dividing works. So I have the square root of 100. That's 10. Square root of 4 is 2. 10 over 2 is 5. So that works. Or if I divide them first, 100 divided by 4 is 25. And the square root of 25 is 5. So it works for multiplying and dividing, but not for adding and subtracting. Okay, so a lot of these problems we're just going to simplify what we can do when we're doing radicals here. Okay, so very important that we know square roots. So square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49. So we're going to try and break down all of these numbers in our examples here with these numbers here. Okay, so how can I break down the square root of 24 using these perfect squares here? So some of you might be saying, oh, 12 and 2. 12 and 2 does not contain any of these numbers. I don't see a 2 and I don't see a 12 up here. Eventually you would get to the right answer, but it's a lot more work if you were to pick 12 and 2. Okay, so if I look at these numbers here, I see that 4 can go into 24. So instead of saying square root of 24, I'm going to say square root of 4 times 6. So 4 times 6 is 24. Okay, I don't know the square root of 6, but I do know the square root of 4, and the square root of 4 is 2. So instead of that 4 being under the square root house, I'm going to get rid of it. I'm going to put a 2 on the outside because that's what the square root of 4 is. Square root of 4 is 2. So I'm left with 2 root 6, and I can't break down 6 anymore. 6 can't be broken down into 4 times something, okay? Some of you might be saying you can still do 3 times 2, Mr. Molo, but again, 3 times 2 doesn't break it down anymore for us like that, okay? Let's say, for example, we did just decide to do 12 and 2, okay? Again, 12 and 2, I don't know the square root of 12. I don't know the square root of 2, so I'm going to have to break down 12 even more. And I'm going to do 4 times 3 times 2. And then square root of 4 is 2. And I'm left with 2 times 3 times 2. I don't know square root of 3. I don't know square root of 2. So I'm going to simplify that. 2 times 3 is 6. So even if you don't necessarily see that the writing in black here is the faster way of the 4 times 6 instead of the 12 times 2, you still get the right answer, 2 root 6. It just takes you a little longer. Okay? So same thing here. There's a negative on the outside. That just means we add a negative to our answer. Otherwise, it doesn't really do anything. Square root of 48. So a couple of different ways we can get to 48. 48 and 1, 24 and 2. But we can use 16 and 3. 16 times 3 is 48. This is the one I want to use because 16 is a perfect square. I know the square root of 16 is 4. So that 4 is going to go on the outside. That 16 is gone from underneath the square root sign. So 4, or square root of 4 and then 3. So that's my final answer. So -4 root 3. All right, 162. So this is where it gets a little tougher here. So 162, I should have went further now. If we keep going with these, stop at 100. 162 can get broken down as 81 times 2. We'll worry about the g here in a second. So 81 times 2 is the same as 162, and I know the square root of 81 is 9. So 9 times the square root of 2, and then I have g6. Okay, so these are all square roots here up until we get to number 9. So square roots, when you have variables, they have to leave in pairs. Okay, so think about it. If you have g to the 6th power, if you have 6 shoes, 6 gloves, 6 whatever, anything that's a pair, 6 ears, how many ones do you have of that? So if I have 6 shoes, that means I have 3 pairs of shoes. So, and we're going to have exactly 3 pairs. So anytime you see a variable with an even number, you're just going to pretty much divide it by 2 because it can only leave the square root house in pairs. So instead of g to the 6th power, I'm going to bring that g to the outside. And if it's 6 shoes, that means I have 3 pairs. So my final answer is 9 g to the 3rd, and then times 2. All right, let's look at number 4. Do it on another page because I'm running out of room here. So -512 h to the 7th. Okay. Again, if we kept going with that chart on that last page, we would figure out that 512 is the same as 256 times 2. And we know the square root of 256 is 16. So I'm going to bring a 16 to the outside. I don't know the square root of 2, so I'm going to leave it as that. Okay, now I have h to the 7th power. So remember what I said for last problem, it can only leave in pairs. So if I have 7 shoes, that means I only have, let me write out my 7 pairs of shoes here. 4, 5, 6, 7. And if they can only leave in pairs, I have 3 pairs with 1 left over. And so how I would write that is h to the 3rd power on the outside, and then 2h to the the 1st power. That 1 pair of shoe, or that 1 shoe, is left over. So that would be our final answer then there. Okay. If we go to these fraction ones, they look hard, but they're not. You're just really just taking the square root of the top and the square root of the bottom. So square root of 25 is 5, square root of 64 is 8, so the square root of 25 over 64 is 5/8. Square root of 6, we can't simplify, but I can simplify the square root of 49. So I'm going to leave the square root of 6, and then square root of 49 is 7. So square root of 6 over 49. And then square root of 196 we know is 14. And then kind of the same thing as before. If I have 4 pairs of shoes, so that means, or if I have 4 shoes, that gives me 2 pairs. So r to the 2nd power. Number 8, we have 49. Square root of 49 is 7. And I have 3 shoes. That means I have 1 pair with 1 left over. And then square root of 64 is 8. And if I have 2 shoes, that means I have 1 pair. So over 8y to the 1st power. All right, 9 starts a little different now. Now these are 3's on the outside, so that means a cube root. So that means the number times itself 3 times. So like 8 times 8 times 8. Or I'm sorry, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 is 64, and so on and so on. 125 for 5. So a number times itself 3 times. So now we have to see if we can break these down, not with the numbers that we wrote up here before, because these are all perfect squares, but now with the numbers that I wrote down here, because these are now the cube roots. So 135 I can break down as 27 times 5. Okay, so and there's my 27 there, so I know that's a good number to use. The cube root of 27 is 3. 3 times 3 is 9. 9 times 3 is 27. So my answer is the cube root. Make sure you have the 3 in there. Same thing when big ideas. Make sure you're putting the 3 in there. So -3 cube root 5. 729 is actually a perfect cube. 9 times 9 times 9 is 729. Okay, this one has variables now, so kind of a different rule here. So let's break down 192 first. So the way I break down 192 is Let's go with 8 and 24. Okay, cube root of 8 is 2. So I'm left with 2 root 24, x to the 5th. Except now that I notice 24 can still be broken down by 8. So I'm going to do that again. So instead of 24, I'm going to do 8 and 3. So a little more work. So cube root of 8 is 2. So 2 times 2 on the outside. So now it's 4 cube root 3 x to the 5th. Okay. And now that it's a cube root, instead of things leaving in pairs, things can only leave in groups of 3. So I have 5 x's here, which means I have one group of 3 with 2 left over. So instead of 3x to the 5th under the square root house, I'm going to move 3 of the x's to the outside, so 4x. And I'm going to leave 2 x's underneath the square root house. Okay, so knowing your multiplication really helps with stuff like this. All right, these they want you to simplify. Whoops. And some of these get, otherwise they've been pretty much the same. Square root of 15 over 500 has been pretty much the same as those. And then down here, they want you to add. In order for these to be added, they need to have the same thing in the square root house. So I just can't add these right now and say it's, 3 root 10. Okay, I can't add square root of 8 and can't add square root of 2 because one's an 8 and one's a 2. Okay, but I can break down 8. And I'm going to say that 8 is the same as 4 times 2. And I know the square root of 4 is 2. So now that becomes 6 root 2 plus 3 root 2. And pretty much this is just a label. It could also say 6x plus 3x. It's just a label. So 6 square root of 2 plus 3 root of 2 is really just 9 root 2. Okay, so make sure before you add them, they have the same square roots. Okay, here I have 2 root 18. So I'm going to break that 2 root 18 into 2 9 times 2. And then I have 2 root 20, and I'm going to break 20 as in 5 and 4. And then I can't break down square root of 5 anymore because nothing goes into 5. So I know the square root of 9 is 3, so I'm going to bring a 3 on the outside. So now I'm left with 6 root 2. I know the square root of 4 is 2, so I'm going to have a 2 on the outside. So 2 times 2 is 4 root 5. And then, like I said, we couldn't change that one, so I left it as a root 5. So here's a good example. Root 2, root 5, root 5. So I can't combine all of them, because this one's a root 2 and those two are root 5, but I can combine those 2 root 5s. And so if I combine those, negative 4 root 5 minus 2 root 5 is negative 6 root 5. Okay? And then all these bottom ones, it's a multiplying problem. So when I multiply here, I'm only going to multiply whatever they have in common. So here, 2 root 5 times root 6 is really the same as 2 root 30. And then 2 root 5 times 2. 2 times 2 is 4 root 5. And then we can try and break down 30, except I can't think of a way that we can break down 30 with square roots. Like 4 can't go into 30, 9 can't go into 30, 16 can't go into 30. So some of these ones you might be thinking like, Mr. Mola, it's a big number, break it down more. Well, we can't break it down more. There's nothing that goes into 30 that we know the square root of.